Okay, let's talk about solution of linear programming by graph. So, what is that? It says that the solution of linear programming refers to finding the optimal values for decision variable that maximize or minimize the objective function while satisfying all given constraints. Okay, you can get this in your sheet and you can go all through the details, but I'm just going to read this, just a brief read, and after that we can go to example. uh, we have objective function. We say that it is a mathematical expression that defines the goal of the optimization problem. It is a function that you want to either maximize or minimize. That means it's just a kind of equation. It's a function. I'm going to show you later in the example that you either want to maximize or minimize. That equal ax plus by, where x and y are decision variables and a, b are coefficient. Again, there's something called feasible region. This feasible region is found in graph. We say that it's the region or the set of all possible solutions that satisfy the constraints of the problem. So actually there are a lot of steps here that you can follow in order to understand what's going on. We have this example. We say suppose the objective function that 3x plus 2y, and the constraints are x is greater or equal to 0, y is greater or equal to 0, x plus y is less than or equal to 8, x plus 3y is greater or equal to 4. Now find the maximum and the minimum value of the objective function. Now we have the objective function given to us at 3 x plus 2y, and then we have all the constraints, the inequalities. Okay, so what we're going to do right now here is to grab this, then find the corner points, and then substitute all those corner points in the objective value, function, to see the point that give us the maximum value or the minimum value. Okay, so I think we are all familiar with how to graph inequalities. For example, we have these two constraints here. I think it's very easy to grab them. So say this is another graph we want. Okay, so we have x, y here. So since we have 8 and 4, 8, let's say we can have, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Now we have x is greater. We have x is greater than or equal to 0. That means this is 0. We have 0 here for x and 0 here for y. This point origin. So x is this one. That means this is going to be the vertical line here. So now the vertical line. We are going to shade this side. We are going this way. Okay, we're going to shade this way because we say that x is greater than or equal to 0. I mean 1, 2, 3, 4, and so on are greater or equal to 0. We're going to shade the side, and the line is going to be solid because we have this inequality. Okay, now let's have another one. The y is greater or equal to 0. Again, we are going to shade this one. This is just this line. We're going to shade off. Okay, now we are done with these two constraints. Now we're going to come to grab this x plus y is less than or equal to 8. In this case, we are going to solve for x or y. Then when we are going to have intercept, let's say y-intercept. By y-intercept, then when x is 0, you substitute 0 there. We are going to have 0 plus y is less than or equal to 8. That means y is less than or equal to 8. In this case, we have a point where you have 0 for x and 8 for y. Now you can also have x-intercept again. where y equals 0. Then you substitute x, just x, but y is 0, we're going to have 0 less than or equal 8. Therefore, x is less than or equal 8. Now, we have 8 for x and 0. Now, we have these two points, then we can plot them again in the graph. Okay, we have 0, 8, that means x is 0, and that means this is point, the cut on the y. Then again, this is this point. Okay, seeing this is this inequality is less than or equal, that means the line is going to be solid. We're going to connect this thing. We'll have to be careful on this. Be solid here. And then now the shading is going to be at which way? The shading here, you can either take this one less than or equal to 8, that means you're going to shade below 8, or you take x less than or equal to 8, you're going to shade the side, that means the shading is actually coming down here. Okay, now what remains now is this this constraint. The constraint here is we have x plus y is greater or equal 4. In this case, we're going to have y-intercept again. X equals 0. Substitute the x there. 0 plus y is greater or equal to 4. That means y is greater than 4. Now we have 0 and 4 other point. Again, we can have x-intercept where y equals 0. You substitute, you have x, but y is 0. We're going to have 0 greater than 4, which means that x is greater or equal to 4. Now we have another point, 4 and 0. Now we're going to take these 2 points again and put them in the graph. We have 4 and 0. 4 and 0, that's this point. And 0, 0, 4. 4 and 0 and 0, 4. 0, 4 somewhere here. Now we can connect this line. Actually, I have to be careful here. Anyway, this is solid line. Okay, now the shading here is going to be okay. The shading here is going to be, you can either take y is bigger than 0, is bigger or equal to 0. I mean, y is bigger or equal to 4. That means we're going to shade off. We're going away this f. The same thing if you take this one. Then you have this kind of shading here. Okay, now we see the graph. You have this line that shade this way, and this line that shade also this way, and this line also that shade this way, and this line. And now we have boundaries here. We have a border here, and a point here, and a point here, another point here. Okay, these points are called the corner points, and these regions here that satisfy all the constraints is called the feasible region. This region we call it, feasible region. Feasible region, and these are the corner points. For example, here we have the corner point of 8, 0, another corner point of 4 and 0, corner point of 0 and 4, and then a corner point of 0 and 8. Okay, what remains here? First, the goal for this graph is to find the corner point, and these corner points are important for finding the maximum or the minimum value of the objective function. That's why this graph is necessary. Now we're going to take this 4 corner points, substitute them into this objective function to see which point gives us the maximum value or the minimum value. Okay, we have the point 0, 4, 0, the point 8, 0. Also we have 0, 4, down 8, 0. Let's take this objective function the equation for that is that equal 3x plus 2y. Now let's substitute each point. Let's substitute this point x and y. You're gonna have that 3 times 4, then plus 2 times 0, just 0. That means that in this case for this point is gonna be just 12. Okay, now let's substitute this point again. This point, that means this point now that equal 3, and this one is going to be 8 plus again 2 times 0, just 0. That means that in this case is going to be 24, I suppose, 24. Now let's take this point 0, 4. Now let's substitute that equal 3 times 0 plus 2 times 4. That means it's going to be just 8, I mean. And now let's substitute another one 0, 8. This is 8. You are going to have that equal, again it's going to be 0, 4, 3 times 0 plus 2 times 8. Now that's going to be 16. Okay, now all these points here, we have this point that gave us 24. We have this point and it gave us 12. We have this point, it gives us 8, and this point it gives us 16. Okay, in this case it just means that this point gives us the maximum value for the objective function, and this point gives us the minimum value for this objective function. Okay, therefore we can say that the maximum value, let's say the maximum occurs at the maximum occurs at I don't know where is it, at 8, 0. I mean at 8, where is it, at 8, 0. The maximum value occur for the objective function, and the minimum at what? The minimum it's at 0, 4. Minimum at 0, 4. This point, at this point. So this is what this example is about.